And I would like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. Thanks again for joining us for today's presentation, 24 Hours of SQL Server 2008, Scale Your Business. Now it's my pleasure to introduce today's presenter, Chris Avis. Chris, you have the floor.
Oh, there we go. I had to unmute myself. All right. Thank you very much, and welcome everyone to, I believe this was a rescheduled session. I believe this was originally session 13, and we rescheduled this because of some issues. So this will be, well, you know, it's not even really important which number it is in the session. We're completing this series on SQL 2008 in the 24-part series. And you can get more information if you've missed some of these or you'd like to go back and review some of the sessions you've already seen. We record all of these. They're archived online at our Microsoft.com/webcast site, which is actually the very bottom link here on the slide. If you go out there, you can find this and all the rest of the webcasts that we do. We usually put them online about 48 hours or so after we record them, and so you can grab it there. And we even make them available for offline viewing. So if you want to pull them down and view them at your own leisure, you can do that without having to be connected to the Internet afterwards. All right. So as usual, I've placed my blog information on screen, and through the blog you can gain access to my cell number, email, Twitter, Second Life, MySpace, Facebook, any possible means you could even think of getting a hold of me. They're all listed out there, so feel free to use that. If you have any questions about this or any other thing Microsoft related, feel free to get a hold of me, and I'll do what I can to help you out. So what are we going to be covering in this specific session today? There we go, slide advanced. So we're going to be talking about different performance and scalability enhancements in SQL Server 2008. We'll be going into some information around our query processing engine. We'll talk about partitioning tables and how that can improve the performance on our systems. And then we'll wrap this up around data compression, both in the database as well as in the backups of the databases that we make. Now, of course, there's some things that you should know now to be able to get something out of this session. So any experience you have with SQL Server, preferably SQL Server 2005, or if you've worked with the SQL 2008 beta, that's obviously a big help as well. And then, of course, working with any of the scalability features, whether that's high availability, load balancing, compression, partitioning, any of that information inside of the previous versions of SQL, that's a big plus as well. All right, so the nitty-gritty on the agenda, we're going to be talking about scaling up and out, as well as some high-performance query information, and then we'll go into our compression at the very end of the session. All right, so scaling up and out. So there's actually two different ways that we can scale our SQL systems. There's scaling up, and then there's scaling out. And when we talk about scaling up, we mean we're talking about adding hardware to really beef up a single server to handle increased workloads. Now this could be the result of server consolidation, maybe you have very large data stores where you've increased the number of applications that are running on the server that warrants this. But really as the number of users and applications increase, that's obviously going to impact the performance and the responsiveness of the system. So this can be affected. And we can have things like concurrency issues where we have multiple attempts to access the same data. It's relatively common in SQL scenarios. So with SQL Server 2008, we exploit some of the latest hardware technologies to really help scale your servers up. And this is going to help you meet the demands of whatever you have for your business, whether it's growing, you're growing the applications, you're servicing more customers, etc. Now, one of the big areas where we target this is the hardware support at the 64-bit processor level, and the big push towards multiple cores on these CPUs as well, and multi-processor systems even. Now, SQL can address up to 8 terabytes of memory. That's a lot of memory. I mean, I'm just waiting for the 1 terabyte memory chips and the motherboards that will actually support that. And when you think about it, it's just not going to be that far away. All we have to do is go back a little over a decade, and minimum OS requirements were 4 megs of RAM, and we're in the gigabytes of RAM at this point. I'm not saying that the OS or other applications will require terabytes of memory, but having access to terabytes of memory, that's a big plus regardless of the types of applications that you're running. So you have this huge amount of memory on our 64-bit hardware that we can address from a SQL perspective. SQL is also NUMA aware. Now NUMA is an architecture that really overcomes some of the memory access limitations that we have on some systems that have large numbers of processors. SQL Server also supports hot add-ons for compatible machines for both memory and CPU, and this will help eliminate some of the downtime we have on these mission-critical servers where we're seeing some performance issues. We've identified that we could address it by adding another CPU, maybe adding some more memory, and with the appropriate hardware, it's just plug it in and go. We're not shutting anything down. Our apps stay running, our databases stay accessible, we can still run our reports, we stay up and running, and that's what we want, high availability and always up and running. In addition to all of this, multiple database engine instances and multiple analysis services instances can all be installed on a single server to consolidate some of the hardware usage as well. So we can have up to 50 instances installed on a single server without compromising the performance or the responsiveness of the underlying architecture in the system. Now in addition to that, SQL 2008 also provides numerous different types of isolation levels to provide a variety of different solutions that balance out concurrency with read integrity. In addition to that, lock escalation, this allows us to set, it's a setting on our table entries that you can do to improve performance, helps maintain concurrency, especially when we're querying partitioned tables. Now, in addition to scaling up, we have some tools and some capabilities for scaling out the databases to increase the performance, particularly on very large databases, and try to move that data closer to the users. So let's talk about scaling out. So from a scaling out perspective, let's just take data warehouses. Data warehouses are typically used by multiple consumers of, more often than not, read-only data, and they can become overloaded with requests, depending on what type of applications you're running, what types of queries are being run against them. Now, SQL Server 2008 supports scalable shared databases, and this provides a way to scale out read-only reporting databases across multiple database server instances. And this enables us to distribute that workload. We can isolate some of the resource-intensive queries and simplify that process. The scalable shared database feature, this also enables administrators to create a dedicated read-only data source. We do this by mounting copies of the read-only database on multiple reporting servers, and then applications can access a consistent copy of that data independent of the reporting server to which that they're connecting. Now, there are some considerations here. So although local partition tables, these enable us to overcome the performance limitations caused by disk restrictions on the server. Distributed partition views, this enables data from very large tables to be split across multiple servers. And queries can then take advantage not only of multiple hard disks, but also of additional CPUs, memory, buses, other hardware that's available on additional servers. And so, I mean, it's pretty easy to think of it. You have 3 different servers. We're sharing the data across. If we send all the queries to one server, that server could potentially have performance issues. Whereas we kind of balance those queries across 1, 2, 3, or more servers, then we're going to get more responsiveness out of those environments. So not only can we take advantage of the multiple hard drive spindles, the CPUs, memory, everything else in the hardware respect, but we can also do, with the distributed partition views, this gives the administrators the capability and the freedom to create a federation of database servers that work together to increase the performance on very large database tables. And we can also do peer-to-peer replication, and this can provide an effective scale-out solution in which we have identical copies of the database, we distribute them to locations throughout the organization, and then modifications that are made to the local copy of the data, those are propagated automatically to the other replicated copies throughout the environment. SQL 2008 can also help with the new peer-to-peer topology wizard. We have a visual designer that goes with that. And by using peer-to-peer replication, you can enable applications to read or modify data in any of the databases that are participating in replication. And SQL 2008 also gives us new nodes that we can add and be connected even during replication activity. Now to kind of wrap this up for this particular slide, if we want to do the things like improve the performance, many application servers cache data. We try to have some of that data stored in memory. And by virtue of being able to do this huge amount of storage in memory, this is going to reduce some of the disk I/O time, which is very expensive for data retrieval. If we have to pull it off the disk versus pulling it out of memory, we're going to want to pull it out of memory every time if we can. It's just a much faster process. So, we cache the server data. That gives much quicker response times to the users. However, that data does have to be refreshed periodically, so refreshing the data frequently adds some overhead, which can ultimately slow down performance on the servers. So we're trying to cache information, but it has to be refreshed, and that refresh process actually ends up causing a performance impact on the environment. So SQL 2008 helps applications to use that cache more efficiently by using query notifications to automatically notify things like middle-tier applications when the cache data is outdated. The application server can subscribe to the query notification. It can be informed when the updates that affect the cache data are performed, and then it can refresh the cache when it needs to, as opposed to trying to do this all the time and causing performance issues in the environment. So SQL 2005, let's talk about this for a moment. SQL 2005 analysis server cubes, these are usually read-only databases. Each instance maintains its own data directory, and although you can synchronize the cubes across multiple servers, that cube synchronization process, it introduces some latency, and it may be unacceptable depending on the type of environment that you have. So in 2008, the analysis services, we support a scale-out analysis services deployment model in which a single centralized read-only copy of the analysis services database, it gets shared across multiple database instances, and it's accessed through a single virtual IP address. So from a networking perspective, it also simplifies the configuration of the environment. Okay. So next item in our agenda, let's talk about high-performance queries. All right. So SQL 2008, we've talked about some of the other features we have, but we also have many different types of features and enhancements to optimize performance across all of the different areas of functionality. So anything from OLTP and OLAP, reporting services to ETL processes. SQL 2008, we're really striving to deliver on performance to make this a very high-performance, high-availability database engine for the environment. We also want to make sure that we have consistent performance, that we have consistent responsiveness. I mean, that's what businesses want in the environment. So the high-performance query processing engine, this is a part of SQL 2008. It helps users maximize the application performance for the environment. The query processing engine evaluates queries, generates optimal query execution plans, and these plans are based on dynamically maintained statistics about indexes, key selectivity, data volumes, and you can even freeze these query plans in SQL 2008 to make sure that we have consistent performance for any of the commonly executed queries that we have. The query processing engine also utilizes parallelism to take advantage of multiple core or even multiple processor systems. Now, usually the most costly operation in terms of query performance is again going to be the disk I/O. So the dynamic caching capabilities of SQL 2008, this is going to reduce the amount of physical disk access that's required to retrieve or even modify the data, and the query processing engine can significantly improve overall performance by using read-ahead scans to try to anticipate the data pages that are required for a given execution plan, and if possible, preemptively read them into the cache. And in addition to that, we also have native support for data compression. This can reduce the number of data pages that have to be read, and that's going to improve the performance on I/O or heavily I/O-bound workloads. Now, the final piece of this for this slide for doing the scaling or for high performance, we support partitioning of tables and indexes. This is going to give administrators the control to manage the physical placement of data by assigning partitions from the same table or index to multiple file groups on separate physical storage devices. Optimizations to the query processing engine in SQL 2008, these really enable us to parallelize the access to the partition data. And this, of course, is going to result in a significant improvement in the performance across the board. All right, Performance Studio. Now, one of the tools that we have to increase the performance is a very appropriately named tool called Performance Studio. Now this is an integrated framework that you can use to collect, analyze, troubleshoot, and store server diagnostics information. Performance Studio provides a very nice end-to-end solution for performing monitoring that includes low overhead collection, centralized management, analytical reporting of performance data, and you can use SQL Server Management Studio to manage collection tasks such as enabling the data collector, starting a collection set, doing system collection set reports as a kind of performance dashboard. Now you can also use system stored procedures and the Performance Studio application. There's an API, a programming interface for this, to build your own performance management utilities based upon what we already ship with the Performance Studio. Now, in addition to that, the Performance Studio provides, it's a very nice unified data collection infrastructure. It consists of a data collector in each SQL Server instance that you want to monitor. That data collector, it's flexible. It provides the ability to manage the scope of the data collection to fit development, test, production environments. So we have the whole gamut that we cover. And we can easily collect both performance and, just general diagnostics data with that same framework. We also provide a fairly robust set of pre-configured system collection tasks. This is going to include things like server activity, query statistics, disk usage, so we can manage disk I/O. And this allows us to quickly analyze whatever data that we've collected as a part of these collector sets. We can start monitoring and troubleshooting with the server activity system collection inside of the Management Studio, and we can use the different reports that we generate from this as a performance dashboard to help analyze the performance of our database systems as a whole. All right, so talking about partition table parallelism. So in SQL 2005, we introduced parallelism to partition databases. Now, they didn't always do that well in cases where you had to do queries that accessed a small fraction of the table, but not one partition. So you'd end up with only one of your procedures being able to take advantage of the parallelism. So we didn't get as much out of that as we might have hoped for. Now, this is because in SQL 2005, this was usually done by running several partitions in parallel, but we only have one thread per partition. So it was not possible to get a parallel partition scan of even a single partition in many cases, and of course that impacts performance. So in the example that you see here, Monday morning's users are in great shape as their queries hitting a single partition, and thus they were parallelized very nicely. Tuesday's users, they're in a different boat. Their data needs to be to access two different partitions, and thus they're suffering some of the limitations of being able to only run a single thread per partition. Now, if we compare this to SQL 2008, 2008 evaluates or alleviates this condition with multiple threads across the partitions, and we achieve this because the internal representation of the partition table is changed so that the table appears to the query processor to be a multi-column index with partition ID as the leading column. Partition ID is the hidden computed column used internally. It represents the ID of the partition containing a specific row. Now, when we combine this with new extensions and the query optimizer, this means a parallel execution strategy gets used for queries that select from the different partitioned objects. All right, so this is going to take us into our very first demonstration. I believe that's my slide. Yep. All right. And what we're going to be doing is we're going to look at, and I have a series of scripts that we'll be running as a part of this. I'm not going to be typing this all up myself. If we did that, we'd be in this session all day. So I have a series of canned scripts that we're going to be working at. So while this is coming up and while we get connected to our database, in this particular scenario, we're going to be taking the role of the Contoso's DBA. We're going to be tasked with improving the performance on some large tables in the order in an order tracking database, and as such, we're going to see how we can leverage the new capabilities around the partition tables in SQL 2008. And really working with partition tables, this has traditionally been somewhat of an arcane practice. With the new release, or actually I guess it's in beta with SQL 2008, we're continuing the efforts to bring down to earth and make it easier for developers and administrators to more effectively use the feature to improve the performance of the applications. All right, so let's dig into this. So look at the database we're going to be working with. Let's drill down to Contoso. We will go to our tables. We'll go to our DBO orders and our columns. I just wanted to show you some of the information that we're going to be working with here. So we're going to see how our table is currently partitioned. So we're going to start this by looking at the table. We're going to look at the orders table. The table's performance has suffered over time as the table's grown. Short list of the uses of table partitioning for our environment. This would include, we want to get some better performance out of this, maybe some data archiving, and we're going to see if we can accomplish this. So we've drilled down to database orders to columns. Actually, let's go ahead and highlight this. All right, now what I have now, the first task that we're going to do is we're going to create some file groups that are later going to hold the partitions of the partitioned orders table. So we've named some file groups. Let me go ahead and open up my script here as well. So File, Open, File, and Table Part. There we go. All right, so we've named some of the file groups based upon the data that they're going to be holding. So we're going to segment the data into quarterly groupings. So here you can see we have 2003 Q3, Q4, 2004 Q1, 2004 Q2. So why have we created the file groups? Well, a file group is only a name to a location within a database. So the physical location of the data within the file group, this is based upon the files within the file group. So a file group can have many files, but each file can only be in one file group at a time. And when a file group has many files, space is allocated to the objects by using a round-robin type of algorithm. So the files will be proportionally filled over time. This should yield better resource utilization for larger objects, especially when not partitioned. And when using a partition table strategy, it's more likely that each partition reside in one file so that no single partition will warrant multiple files. So based upon that reasoning, let's go ahead and look at this real quick. So let's actually get our, make sure I've got, there we go. So let's get this. Make sure I have the right ones here. I need to select in through 216. Yeah, so we're going to go ahead and add our file groups in. I'm going to go ahead and execute this. All right, looks like we've completed successfully there. Let me scroll down a little bit here. We'll go to our next section of the script that we're going to be working with. All right, so as I mentioned before, when we use this type of partition table strategy, it's typical that the partition reside in one file so that no single partition is going to have multiple files. Excuse me. So based upon that reasoning, the next thing we're going to do is we're going to create one file in each of the file groups. So that's our next section of this. So let me get this highlighted. There we go. So in this case, we're adding the files in. Let's go down through 59 is the line I'm looking for. All right, so what we're doing here in the section that I've highlighted now, we're creating our file groups for each of the sections of the quarterly data that we had already segmented out. Let's go ahead and select that and execute. And then what we'll see is that our database has 4 new files and that they're associated with our new file groups. So we've got that without any errors. All right. All right, and let's see, we should be able to close out of this at this point. All right, so with our file groups and with the respective files we've created, we can move on now to the next task, which is going to be defining a partition function. Now, this function will determine how the rows will be filled in the partitions. In our case, we're going to use a range partition function to deal with the various date ranges for the incoming data. Now, I'm not going to go into the details of the range partition functions, but we'll see that since we've decided that our partitions are to be segmented into quarterly slices, the partition functions are going to deal with dates in its main range. So I've got another script that we're going to load up here. And that's our range part table. There we go. And let's highlight here lines 2 through 13. There we go. All right, so as I mentioned before, we've decided that our partitions are going to be segmented out into the quarterly slices for the data that we were working with. We're going to create our own partition functions, or when we create our own partition functions, we should explore some of the online help information that's a part of the SQL application to see what different types of options are actually available. All right, so we're going to do the partition ranges. Let's go ahead and execute this part of the script. There we go. No errors there as well. That's always good. Let's scroll down to the next section and get that highlighted. There we go. All right. Now with the partition function created, next up is what's called the partition scheme. Now the partition scheme maps the partitions to physical locations, in our case the file groups that we created earlier, and by scheming the partition in this way, we've enabled SQL Server to better utilize the underlying hardware. Now this could potentially mean multiple disks and parallelism. So let's go ahead and get this executed. Again, no errors. That's always a good sign. Let's scroll down to the next section here. There we go. And let's move this down so we can get more on screen here. There we go. All right. So now that we've done our partition scheme, we can now create the partition table itself. And at the end of the create table statement that we see, the on clause defines which partition scheme this table is going to use, and the column of the table that dictates row to partition. So essentially the scheme location. So let's go ahead and execute this section. Again, no errors. That's always an awesome thing. All right. Let's go to this next section and get it highlighted. Now this one I don't think is, well, no, actually it might fit all on screen. Yeah, it does. This one's actually a shorter section than I thought. All right. So now we're going to load the data into a partition table in the original orders table. So we'll go ahead and execute that. Our next section of our code here is to use the partition. So, and let me make sure I got the right one selected. I do. All right. So SQL Server provides the $partition function to indicate which partition row is a member of. So this section of the query uses this function to show which partition the row is on, as well as a count of the rows for each range. So let's actually scroll this up a little bit and then execute. There we go. So we can see here the number of rows in the partition, some other information about the partition numbers, and that's key is these partition numbers, the 2, 3, 4, 5, 6 that we see here, because some of this information is going to be changing here in just a moment. So next we're going to look at the execution plan for a query against a regular table, and then we'll look at it against our partition table. So when we execute this batch that I'm going to be showing you here in a moment, and view the execution plan, we'll see the partitions being executed. So let's go ahead and do this. Let's go to our query menu. Let's go ahead and include the actual execution plan. Let me come back out here to our queries. There we go. We'll do our actual query and execute this. And there it is. And then we can come over to our execution plan. And if we come down here and let's bring this up a little bit more, let's look at our table scan and go into the properties here. So there we go. We've got our properties there. So if we look at our execution plan, we see that we have our regular table, our partition table. We have a second query that's going to be showing that the query is partitioned and gives the actual partitions that are accessed. Now, one thing that we've left out thus far is any kind of table indexing. So obviously indexing is critical to performance, which is what our aim is going to be from the start anyway. So we'll want to index our partition table. So how is the indexing performed on the partition tables? Do we have to index each partition individually? Well, thankfully that answer is no. So the sole difference is that we must include the partition scheme. So let's get the next part of our query. Let's kill off these properties. Here's our indexing. And we need to go down to line 93, which I believe is the end of our query statements anyway, which it is. There we go. We'll do the indexing, execute, and it looks like we're all good there. So now when we go back to our queries, we're going to see no effective difference in the plans. So let's go back up here to 80 to 81. There we are. And let's execute this. And go to our execution plan. There we go. All right. So we see no or when we go back to those queries, we see no effective difference in the plans. And the important takeaway here is that the way in which we interact with the indexes on the partition tables is really no different than what we do with regular tables. Now, a common problem with larger tables is that the overhead with the addition of archive, or with the addition of different data and the archival of the data to and from the table, if we load and delete processes, we can introduce downtime as indexes get rebuilt. With partition tables, you can alleviate this by using what is called a sliding window concept. So for our next example, we'll be using the sliding window concept to archive the oldest quarters data and add in the newest quarters data for this. So I have another set of scripts here. Let's go grab those. And rolling range. There we go. And let's take lines 2 through 14 here. All right, so we're going to be taking that data for, let's see, what was it? The oldest quarters data, then we're going to be adding in the newest quarters data. So we've got that highlighted. Let's go ahead and do that and execute that part of the script. Looks like that was successful. Let's take our next range of the script. This is going to be to create a staging table. Let's go back up here. There we go. All right. So next we're going to create a normal non-partition table with the exact same structure as the partition table. The constraints here are very important. Without the constraint in place, SQL Server will not allow us to later consider it as a new range of the partition table. So that's going to, oh, and I didn't even have it here so you could actually see the data, part of the script on screen. So I'll let you review this for just a second. All right, so just keep in mind that without the constraint in place, SQL won't let us go back later and consider this as a new range of the partition table. We'll go ahead and execute this. Looks like that completed successfully as well. Our next range for this is we want to move that or create that new table with the new data for the new quarter. All right, so now that we've got that out of the way, we'll bring over our Q3 data from the main orders table. We'll apply the same index that is present on the partitioned table. So you can see here at the very tail end of this is our create clustered index. Did it execute? We're waiting for our messages here. There we go. I just wanted to make sure it was showing up there. So it looks like we're all done, and we didn't have any errors on that one either, which is good. So now with our stage in table setup, we now need to define the stage out area for the data that we're switching out. So this table matches the definition of the partition table, and it's created on the same file group as the partitioned table. Let's get our next slice of code here. All right, so we're going to be staging out our table, and now this is the one I don't think is going to fit completely on screen here. So yeah, there we go. It's going to scroll just a little bit. So first part of this is to create the table, and then to create the index for that. All right, so let's go ahead and execute this. And this completed successfully. So now we're ready to switch out the old and bring in the new. For the switch out, we must specify the name of the table and the partition number, which is going to be removed. That's why I asked you to look at the partitions before. I believe we had 2, 3, 4, 5, and 6. And if we go to our next little snippet of code, which is here, there we go. We're going to be switching out those partitions, and so we'll see this change. Let's go ahead and execute. All right, and let's see, if we go to, we'll have to go to this next section, 102 through 110. We're going to verify that partition 2 is gone. And if we scroll this back up some, there we go. We'll see that partition number 2 is gone from our table. Now we can execute a query that uses the partition function to list a row count for each partition, which is what we just did. And we see that partition table number 2 is already gone. Now in our next snippet of code here, just as it says, we'll be removing this boundary point so that we can now go back and renumber the partitions. So we want to keep things numbered from 2. We want to keep them in this nice orderly fashion so that the next time that we want to archive data, we can keep referring to the oldest partition as partition number 2. We're going to do that by removing the boundary point, which is this little snippet of code, which we've done successfully. And we're now going to, after we've removed the boundary point, after we execute the alter partition statement, our partitions are going to be renumbered. We're not actually moving any data, we're just simply renumbering the partitions. So let's go ahead and do that. All right. Take our next range. Now we're going to modify so that we can actually add in. So in order to insert the new quarters data, we need to add a new partition. To add a new partition, we split one of the existing partitions. We use the query that's on screen now to ensure that the next split is going to occur at a specific location. This is going to be where our new data already resides. So let's see. I'm actually, did I get ahead of myself? I don't think so. Let me make sure here. Nope, I think I'm good. Yep, we'll go ahead and execute. Yep, it did it successfully, so we're all good there. All right. Now what we want to do is we want to switch to the new partition. So finally we're going to switch the new quarters data to the newly created partition, and voila, we've just swapped out all the new data as soon as we execute this. There we go. We've executed all the data, and let me come back here, and I think we can do kind of a proof of concept here. Let's go back up here to 102 and through 110. Yep, sorry about this. I'm just trying to get up here to the right area. Where are we at? Oh, a little too high here, so let's go back down. There we are. Oh, no, that's not it either. There we are, 102 through 110. There we are, and when we execute this, we'll see that our partition number 2 is back in play. So now, throughout all of the switching in and out of the data, no data was actually deleted. The switch process is metadata only as far as the update goes with this. So to kind of review what we've learned here, we've learned how to create a partition table to increase the performance and manageability of the ailing table that we had in play. We're using multiple files with a partition to each file. We're able to increase the parallelism of the queries against that particular table. We archived some old data out. We swapped in new data into the partition table in a sliding window scenario. And, you know, unlike previous incarnations of the partition tables that we've used in the past, we're able to treat partition tables much like any other table in our environment. So working with indexes, querying these types of tables is no different than that of a normal table. So at this point, we're going to bounce back into our slides. We'll talk, actually, I've got some review that we'll do. And then we'll do some more slide information here as well. All right, so we just wrapped up our partition tables. Let's do some review here. So some ways to scale up. Don't forget they're scaling up and they're scaling out. So ways to scale up on SQL Server 2008. How are we going to do this? So would this be to add CPUs, add some memory, invest in a machine that has the NUMA architecture? Maybe we're going to do all of these as a part of this process. So what do you think? We have 35 people on here. If we could get 15 or so people to jump in and do a vote here for the poll, we'll do that. All right, it looks like most people are actually getting this correct. It's actually all of the above. So each of those is a valid point for scaling up. Adding more CPUs, that's going to give us more processing power, more threads that we can work with. Adding more memory allows us to cache more information into the RAM of the system versus having to swap out or do any of the paging operations or manage any of the disk I/O. The NUMA architecture allows us to scale out the memory for the large quantity of processor systems as well. So, correct answer is all of the above. All right. Next, which of the following is not a characteristic of the high-performance query engine? It's only available on x64, using parallelism to take advantage of multiple CPUs, provides a plan for freezing, native support for compression. Which of these is not a characteristic of the high-performance query engine? We're a little bit split here, but most people are actually getting the correct answer here. actually this first one, the red one, only available in x64. The query engine is actually present across all editions that we have, so it's not limited to just the x64 version of SQL 2008. All right, last little poll slide before we start getting back into some more information here. All right, partition table parallelism in SQL 2008. This can be best described as what? Multiple threads, single partition, single thread per partition, neutral threaded, or multiple threads against multiple partitions. Oh, we've got a good smart crowd today. We'll just jump in right now. I know not everybody's voted, but it looks like everybody's getting this. It is the bottom answer there. Correct answer is multiple threads, multiple partitions. This improvement is a major performance enhancement in SQL Server 2008. All right. Next on our agenda, let's talk about compressions. Now, towards the tail end of this, I have just a few slides here, and then we'll be jumping in and we'll doing some things with compression in the demo. So we're going to move to this final section dealing with the different ways that we can use compression within SQL 2008. And the compression in SQL 2008 really has two main goals. We want to shrink the data, and then we want to improve performance. So how are we going to do that? So obviously data shrinkage, this is going to be good for the disks with large tables particularly. But in SQL Server, often the most precious resource that we have is memory. So if the data size is smaller than often the query or the backup performance, if the data size is smaller, then the query or the backup performance can typically be improved. We're just moving less information across the wire to a backup system, etc. So we look at SQL 2005 with SP2. We had something called the var decimal data compression that was introduced. In SQL 2008, this variable length encoding, this is extended to fit length types or length data types via a new row format. Now we have two different types of compression methods that are employed here. We have something called column prefix compression. This factors out common prefixes from the same column across all of the rows on the page, and these prefix values are stored once and then referenced from the respective columns. Now we also have something called page dictionary compression. Now this works by finding the repeating values across all columns on all the rows within the page. It stores these values in a dictionary once, and then we reference them again from the respective columns. Now with compression, the decision comes down to CPU trade-off. Trading of fewer IOs against some CPU may get you good performance benefits if you are IO bound. Now, when establishing compression, there are some tools you can use to help determine what benefits of compression you're going to have, compare them against the different trade-offs that you might have in the environment. So you're not going to be left stranded trying to figure this out or do a bunch of testing. So you can use the SP stored procedure for estimate data compression savings system stored procedure. This is to see compression savings of particular tables and the parts thereof. Now, some things to keep in mind when you're enabling compression is that first, compression is available in the Enterprise Edition only. Now, the types of data compressions, we have row. This is going to store fixed length values as variable length. It's a superset of the var decimal storage format or the var decimal storage format. The row metadata is optimized. Blob lob is not row compressed, so one of the alternatives is to use file stream on compressed NTFS partitions. That's for row. We have page compression. This includes some of the things that we have for row. That gives us column prefix, dictionary. Only in-row blob lobs can potentially benefit from this type of page compression. All right. So this is actually going to take us straight into our very next session, very next demo. So I have two different demos I'm gluing together. One is just showing how to enable compression. They're also going to show this from a backup perspective. So essentially in this demo we'll see how to use various tools to view potential space savings and then to enable compression within the database itself. All right, so we're going back to our existing system. I think I can close these out here. Go, get rid of these scripts. All right, I think I've got a little gray box here in the background. There we go. That looks better. Okay, so the first thing we're going to demonstrate with regards to compression is a handy tool within SQL Server that estimates what the potential savings could be. So let me go ahead and grab the scripts for this. There we go. All right. Now, compression can be very costly on existing data, so hence the estimation can be useful when planning and trying to determine if the compression is actually going to be worth it for your particular circumstance. Now, before we estimate or before we examine the estimation, let's note that there are several things that are compressible within SQL Server. We can compress heaps, clustered and non-clustered indexes, indexed views, and even the individual partitions of the tables. All right. We make sure I'm in the right database. We're on Contoso. We're all good. So let's estimate the savings that we could achieve with our orders table. First with row compression. Let's see, lines 2 for 5. Here we go. The estimation routine is a system stored procedure. We have aptly named this the estimate data compression savings. And when we run this, which I'll go ahead and do now, get some results. All right, there we go. We can see that when we call this out, our gains will go from the current size of 344K down to 232K. I believe I'm going to have to scroll over so that we can actually see that. There we go. So we have two options here. We'll see size with our current compression setting, and then with the compression setting that we would like to do by using that estimate data compression stored procedure on our orders table. So we're reducing that from 344 to 232. So our table only contains a few thousand records, but this is fairly significant from a pure ratio standpoint. Now what's actually going on with the estimation routine is that it creates a sampled subset of the data in TempDB, it compresses it using the requested compression algorithm, and then it returns to us not only the estimated size of the table, but the details of the sample size. And in our case, these are equal to our table, but our table is not overly large in this particular case. Let's go to our next part of this. All right. So we can see this whole thing here. There we go. So the first one dealt with row. The next one is going to be an estimate with page compression. So when we instead estimate compression with the page compression method, we can see that our potential savings is going to be even better with this. So let's go ahead and execute this and look. So here we are with our orders table. Current size is 344, but we get to 152K when we do page compression. But why is this? Well, page compression is a superset of row compression. So where row compression concerns itself with record metadata, the storage format optimizations, page compression performs row compression as well as prefix and dictionary compression. So I guess the question becomes now, why wouldn't everyone just use page compression all of the time? Well, not all of the cases are actually equal. You may not want to trade that many CPU cycles, or you may in fact want the highest level of compression, and so you have to make that determination depending on your particular environment. And these tools for this particular script help you come up with an idea of where you might want to set your environment. All right. So when it comes to partition objects, we can run the estimation on the object as a whole. So we'll go ahead and get that estimation here. So we get this next script running. We'll go ahead and execute. There we go. We can also view potential savings on an individual partition if we want. So this statement that we had just done, we're doing the whole thing. Now we want to look at the partitioned compression. And execute. There we go. So size without the compression down to the size width, we go from 64 to 40. That's pretty substantial as well. That's about a 2/3 this original size. There we go. We're at the end of that one. So essentially what we're showing with this is that with this tool, we can estimate uncompressed sizes for tables that are already compressed. We can get an idea of what we have for our current size with our current compression settings, compare them to where we would like to be without having to actually take some sample data, compress it down, and perform some changes on the data itself. Now, compression can be specified at table creation, or it can be performed on the existing data. Both are achieved via extensions to the create and the alter table, as well as the create and alter index functions. Compressing existing heaps and indexes this essentially performs a rebuild, and so that can be a significantly expensive operation if we choose to do that. So I've got another set of scripts here. Let me go ahead and grab that as well. Press 2. There we go. All right. So we're going to look at some of the T-SQL here. We see the syntax for creating a table without the compression. All right. And if we were to then index this table, a clustered index would inherit the compression setting of the heap. Now, non-clustered indexes, they're always managed from a separate table. Now, we could also specify compression. Let's do this. We can also specify compression at a very granular level, such as the partition indexes with different settings on individual partitions. Now, all partitions in an index or table will have the same compression setting unless we otherwise specify for the objects. Now, of course, along with the command line level support, the SQL Server Management Studio has visual tool support as well, so we can do this within the GUI. The data compression wizard allows us to specify what compression level we desire. We can calculate entire the savings estimates that are partition aware. Let's go ahead and do that. So let's go to our databases, our tables. We're already inside of columns. All right. We hit the right spot. Just make sure I've got everything set here correctly. So we've got our DBO orders. There we go. All right. So we're going to right-click. We'll go to our storage. We'll manage our compression. And then we get a nice little wizard here. There we are. We'll click Next. And essentially, this is going to allow us to specify the compression level that we want. It gives us the estimates. It's partition aware. What we're going to do here is we'll choose to compress our orders table with page compression, I think is what we'll do. So we'll do compression type. There we go. Page. Let's do a actually, we'll just go ahead and calculate. So we have a row count of 4,012. We'll calculate. And our current space that we're using is 0.33 megs, pretty small. And that's going to take us down to 0.14. So about about one half, a little bit less than one half the size that we had before. Now, if we do this, let's go ahead and click Next here. We can go ahead and set this to, we can create a script to do this at some other time if we choose to do this later. We can go ahead and run it immediately. We can choose to schedule this out when it's convenient. We'll go ahead and run it now. We'll click Next and Finish. Let it manage this compression for us. Now, detecting which tables are compressed at the current beta edition that we have is only, we can only accomplish this by querying the sys partitions table. So let's go back here, let's close out, and let's go back to my script here. We'll execute this. And there we go. So this tells us the data compression that we have. It gives us a description of this as well. Scroll down. There we go. And there at the very, very bottom, data compression, we have this set up as page compression as we selected with our script. Okay. Let me go ahead and close this one out. All right. So basically, just to review this, we learned how to view the potential benefits of the table compression, how to manage the different compression schemes. There are a few limitations for getting the information back in the current edition of the beta. I suspect that's going to change as we go forward and we get closer to the actual release of the product. But just keep in mind, working with compressed tables from the application's viewpoint, it's no different than working with regular tables. Compression isn't without its drawbacks, though. It's not for every situation. You're essentially going to be trading CPU cycles for reduced I/O usage. And with all of these things, you can potentially impact the performance of the database. And you should look very closely at this, weigh the benefits, use these tools, and then also keep in mind that this type of compression is only available in the enterprise SKU. So let's look at our final demo in regards to this from backup compression. So one of the most requested features is backup compression. So backups for very large databases are very, very time consuming. And we're talking about databases that are in the multi-terabyte range. Think of how long it would take to back up, much less restore that much data. So we support memory compression for the backups. Now this actually makes the overall backup process much faster because the backup data that's written out to the disk, that set of data is much, much smaller. So the file transferred is smaller, thus we're consuming fewer network resources. So let's go ahead and pull up another script here. I'm going to open this up, and it's called backup compress. And the full script here, we're doing a select statement from our backup set. Let's go ahead and highlight that. Here we go. All right. And let's see, backup compression. We can specify as a server-wide default as well as being able to override this in individual tasks. So let's go ahead and look at our SQL database, or our SQL server itself. Let's go to the properties on this. And let's go to database settings. There we are. And let's see, move this up. I'm not going to have all of this on screen. Let's see if I can make this a little bit larger so that we can all see this. So you'll see some blinking and some refresh going on the screen. There we go. I think we can get it all on screen now. All right, so what we've done is we've gone to look at the database settings. We can do this as a server-wide default. We can override this at the individual task level. And what I'm going to do here is we're going to go ahead, or I can, if I want, set this up to compress the backup simply by checking this box here, clicking OK, and proceeding from there. Now for an individual backup job, I'm going to go ahead and cancel out of this. For individual backup jobs, there's a compression setting that is available to us. So we're going to select to compress our backups. So let's go back to our Contoso database. There we are. And let's do a task and a backup. We'll get our nice backup wizard. Now the compression ratio of a compressed backup, this is going to depend on the type of data that's being compressed. Now some factors to include are going to be the type of data, character data compresses the most tightly, and whether or not the data is compressed and or going to be encrypted. So let's go ahead and do this. Let's see our backup database, and let's see if we can get all of this on the screen. Let me see if I can make this just slightly bigger. You'll have a little bit more blinking again on your side. All right. So for our backup database, we're set up for our backup. And there we go. Let's go to options. That's the one that I needed to be at. All right. So we're on our options page. And what we want to do here is we want to go ahead and set the backup compression side of this. There it is, to compress the backup. Here we can click OK. And if we come back when this is done, all right, and I think, no, I can't scroll that out, so hold on just a moment. I think I might need a different script. Let me just check something here in my notes real quick. I think I'm actually good. There we go. I've got the right one. All right. All right. So there's a very handy way to check the efficiency of the backup run and to calculate the ratio of the backup size to the compressed backup size. We do this by querying the backup set table. So let's go ahead and run this query. Execute. All right. And as we can see here, we're achieving anywhere from a 7-to-1 compression ratio to a 3-to-1 ratio. Now, if we had a bunch of image data in our tables, or if we had encrypted or compressed data, the ratio would have been a lot smaller than this. Now, some final things to note on this. You're again going to be trading some CPU cycles for reduced disk I/O when you compress backups. For very, very large databases, this is usually a trade people will embrace very enthusiastically, as the backups are mostly I/O-bound processes. So there's lots of disk I/O, lots of read-write I/O that's taking place here. Now, when databases grow to the size where backups may have a very large time window, and this means significant offline time for the database. With backup compression, this downtime is reduced. Anything that reduces the amount of downtime for our environment just can't be a bad scenario. So the inclusion of compressed backups also helps organizations reduce dependence on different types of third-party solutions. And for some shops, this is also going to be a plus. Now remember that if your database is already compressed or encrypted, your chances for meaningful compression are going to be reduced. In fact, you can actually make it larger. Taking and trying to compress something that's already compressed can actually add some overhead to the process, and actually you end up with something larger than what you originally started out with. So you can actually see a pretty good example of that. Just use WinZip and try to compress MP3s, JPEG files, things of that nature, where the technology for that underlying file format is already a compressed file format. And if you take a block of those, you can actually end up with more total space being consumed at the end of that than the original compressed files themselves. And then again, just one more time, only the Enterprise Edition supports compressing backups. However, all editions can perform a restore of a compressed backup, so that's a big plus. All right, we've got a couple more review questions, and then I'm going to jump out to our Q&A queue and check out things when we do our final wrap-up here. So, a couple of these review questions. Let's start off. SQL 2008 compression can compress the following data types: var decimal, var char, all fixed length, var binary. There it goes. It took a second for people to chime in here. So, decimal, char, binary, all of them, most people are getting this correct. It's all fixed length. So all fixed length data types are supported for compression. Next polling item. Which of the following is a compression method? Column, column, page, heap, or index? Which of those is a compression method? Everyone should be able to get this one. Now, we're not looking at what we can compress, but the method that we use to do the compression. And we talked about two different ones. We talked about row and page. So page is the correct answer here. So the page compression method, this looks for repeating values in a table to factor out into common storage. All right, last polling slide we have here. Compression is available in what edition of SQL 2008? I think I've said it 4 or 5 times. We should be able to figure this out. And most people are getting this correct. It's actually only in the Enterprise Edition. Now, all versions can restore the compressed backups, but only the Enterprise Edition supports creating the compression itself. All right. So that takes us to our summary for the session. And actually, I don't actually have a summary slide here. But basically, in summary, we talked about scaling up and scaling out, some of the new features in SQL 2008 that help accommodate that, how we can introduce compression for our databases or the tables, as well as our backups to reduce the size, the amount of time and I/O that comes into play, and just have to keep in mind the trade-offs that we have between I/O and CPU cycles. So with that, I am going to go ahead, and pass this back to Phil, my producer. He's going to do the wrap-up for you on this. I'm going to check the question and answer queue and see if I can't take care of some of your questions for you.
All right, thanks, Chris. And if you have any questions for Chris, please go ahead and submit those now using the Q&A pane. Go ahead and just click on that, type your question into the upper field, and then click Ask. I'd like to remind everyone that they may print a PDF of today's slides by clicking Control-P, simply just Control-P, and you can either save or print these slides locally for your convenience. Also, watch your inbox for an email with information about viewing this webcast on demand. The email will also include a link to a downloadable PowerPoint of today's webcast. And now you should start to see a survey appearing in your slide area. If you could all take a moment to fill this out before you log off, we do appreciate any feedback you leave for us. All you need to do is follow the links provided to complete the evaluation. And with that, I'm going to hand the floor back over to Chris to wrap up with any questions.
Okay. All right, thanks, Phil. So a couple good questions. So Bori asks one, or Bori S asks a question, will the scripts be available for download? I don't know if they're going to be available for the package that gets put up online here in a day or so when we get done with the webcast repackaging. What I'll do is I'll go ahead and commit to placing those scripts on my blog. So you can get to my blog at blogs.technet.com/Chris Avis. I'll try to get that typed up into the question and answer pane so you can write that down as well. So I'll put the scripts that I use today out there. Just keep in mind that they're going to be addressing my Contoso database, my orders table, so you'll have to modify those to fit your environment. Please list some advantages and disadvantages of using compression. So that there's trade-offs when using the compression. So anytime you compress data, it takes a little bit more time to go through this, spin the CPU cycles of looking at the data, scanning it for repetitive information, and compressing that down, and then storing that repeated information off into another location. So the trade-off here is that it takes a little bit longer to compress or decompress the data, but you get a resultant smaller chunk of data being stored either on disk for the databases or on tape for the backups. So do you want to be able to back it up faster and restore it faster, but have more load on the server during this process, which means you could suffer performance issues on reporting or queries or data change? Or is that not such a big factor to you and you just need to conserve the space because you need to write it faster or read the backup or the data off of the database faster? All right. Another question around the scripts. So yes, I'll put those scripts out onto my blog. When you restore a compressed database, do you need to tell it in the SQL command, or does it just know that it's a compressed database? As far as I know, you don't have to tell it anything. SQL knows that it's compressed. It will simply decompress it. All of the versions have the capability of doing that. However, only the SQL Enterprise version would have the ability to create them. All right. And, oh, well, my screen just locked up. So I don't know. I may have just lost my internet connection, Phil.
Oh, okay.
So I tell you what, we logged the questions, and so I will grab the question log and see if I can address those and post those out to my blog as well. Anything that I didn't get to, along with that scripting information that I was running, I'll collect all of those up, put them in a zip file, and place a link to those on my blog. So with that, thank you all very much for attending the webcast today. Phil, do you have anything to wrap up with?
I'd just like to remind everyone to take a moment to fill out the survey prior to exiting the session. And I'd like to extend a special thanks to you, Chris, for today's presentation. Thank you all for joining us today, and you may now disconnect from the audio portion of today's conference.